Every morning before the sun rises over New York City, hundreds of thousands of people begin their journey to work. Trains arrive from New Jersey, carrying workers, engineers, nurses, and students. These trains pass under the Hudson River through tunnels that are more than 100 years old. Few passengers think about it, but these tunnels are one of the most important transportation links in the United States. The existing tunnels were built in the early 1900s. At that time, engineers faced enormous challenges. They had limited equipment, limited technology, and very dangerous working conditions. Workers dug through mud and rock beneath a river, often working in darkness and water. When the tunnels were completed, they became a miracle of engineering. For decades, they carried millions of passengers safely, but time changes everything. Over the years, salt water entered parts of the tunnels. Storms damaged electrical systems, the structures aged, and maintenance became more difficult. One major storm caused serious flooding that affected signals, cables, and tunnel walls. Engineers realized that the tunnels were no longer reliable for the future. Today, more than 200,000 passengers depend on this route every day. If even one tunnel closes, delays spread across the entire rail network. Trains slow down, platforms become crowded, people arrive late to work, businesses lose time and money. A single point of failure can affect millions of people. This is why the Hudson Tunnel Project was born. It is not just about building something new, it is about protecting a transportation lifeline that connects cities, economies, and people. The goal is simple but enormous. Build a modern rail tunnel beneath one of the busiest rivers in the world, while trains continue running above and around the construction. Planning such a project takes years. Engineers must study soil, rock, water pressure, and river conditions. They must calculate how deep the tunnel must go, how to protect it from flooding, and how to make it last for generations. Every decision must consider safety, cost, and long-term reliability. When construction begins, the scale of the work becomes clear. Massive excavation sites appear near the riverbanks. Cranes rise above the skyline. Trucks move constantly, carrying soil and materials. Thousands of workers coordinate every day to keep the project moving forward. But the most dramatic work happens underground, far from the public eye. Beneath the surface, engineers prepare to dig through layers of earth that have never been disturbed. Here, the real challenge begins. The ground is unpredictable, water pressure is high, and even small mistakes can cause major problems. Building a tunnel under a river is not simply digging a hole. It is a precise operation that requires advanced machines, careful monitoring, and constant communication between teams. Every meter of progress is planned, measured, and checked. And as the first machines begin to move, a new chapter in American infrastructure begins to unfold. Deep underground, the tunnel boring machine begins its work. This enormous machine, often called a TBM, is one of the most powerful construction tools ever built. Its rotating cutter head slowly grinds through soil and rock, moving forward meter by meter. Inside the machine, operators watch dozens of screens. Sensors measure pressure, alignment, and movement. Engineers must balance the pressure inside the tunnel with the pressure of the surrounding ground and water. If the balance is wrong, the ground above could shift or water could enter the tunnel. As the machine advances, workers install large concrete segments behind it. These curved pieces form a strong ring that supports the tunnel walls. Each ring must be placed perfectly. Hydraulic arms lift the segments into position and workers secure them with bolts. This process repeats again and again, sometimes hundreds of times, as the tunnel slowly grows longer. Ventilation is another major challenge. Underground spaces can become hot, humid, and filled with dust. Large fans push fresh air into the tunnel while removing heat and fumes from machinery. Without this system, workers could not remain underground for long periods. Water is always present beneath a river. Pumps run continuously to remove seepage. Waterproof membranes and drainage systems protect the structure. Engineers design the tunnel to resist flooding even in extreme conditions. Above ground, construction sites operate day and night. Materials arrive by truck and barge. Steel reinforcement, concrete, cables, and equipment must all be delivered on time. Every delay can affect the entire schedule. Safety is always the highest priority. Workers wear protective gear and strict procedures guide every task. Regular inspections ensure that structures remain stable and equipment operates correctly. Emergency systems are tested repeatedly to prepare for unexpected situations. At the same time, engineers prepare the railway systems that will eventually run through the tunnel. Tracks must be aligned with extreme precision. Electrical systems must provide reliable power. Signaling equipment must communicate with trains and control centers to ensure safe operations. The complexity of this project is enormous. It is not only about digging a tunnel. It is about building a complete transportation system underground, capable of carrying thousands of passengers every hour. As months pass, the tunnel extends deeper and farther. What began as a construction site becomes a vast underground corridor. Slowly, the shape of the future railway begins to appear. When the tunnel is completed, its impact will be felt far beyond the construction zone. Trains will move more efficiently, delays will decrease, and the entire rail network will become more reliable. Passengers may not see the tunnel walls, but they will experience the difference in shorter travel times and smoother journeys. Modern tunnels are designed with advanced safety features. Emergency exits connect parallel tunnels, allowing evacuation if necessary. Fire-resistant materials protect structures. Monitoring systems detect problems before they become serious. Technology also plays a major role. Sensors track vibration, temperature, and structural movement. Control centers monitor train operations in real time. Engineers can respond quickly to any issue, keeping passengers safe. But the Hudson Tunnel project is more than a transportation upgrade. It represents a larger story about infrastructure. Around the world, cities are rebuilding aging systems to support growing populations. Railways, bridges, airports, and power networks must be modernized to meet future demands. Projects like this require enormous investment, careful planning, and long-term commitment. They also require the dedication of thousands of workers who spend years underground, often far from public recognition, building structures that will serve millions of people. As the first trains pass through the new tunnel, the achievement will be quiet but significant. Commuters may look at their phones, read newspapers, or watch the city lights through train windows, unaware of the engineering marvel beneath them. But deep underground, beneath the river, a new passage will carry the movement of a city. Steel rails, concrete walls, and powerful machines will stand as a reminder that even in the modern world, great engineering projects continue to shape how we live. And as the train emerges into daylight, the skyline of New York will rise in the distance, while beneath the Hudson River, the tunnel will continue its silent work, carrying the future forward.